Hello everyone, good afternoon.
Uh, we are the Ruti PhD Committee, and today we are hosting a workshop about how to make a heat map with R, with Alberto Bueno. So take paper and pen and pay attention.
Okay, so hello everyone. We are very happy to be here with you today, and welcome to the new webinar series of Ruti PhD Committee. So, and we are very happy to be here with you. And let me share your screen. You can see it, right? Okay, you see it very good. So, this webinar training is intended for wet lab researchers that do not use bioinformatic tools nor perform bioinformatic analysis often. But we want you to learn and know how to perform some basic R functions for those people that never used R before. So everything will be recorded, don't worry. Everything will be on YouTube. And now, because more than ever, bioinformatics is everywhere. And wet lab researchers have the need to learn by themselves how to analyze the data we produce. I myself, I am a wet lab researcher, and I learned by myself, little by little. And since the poor bioinformaticians are full of work, we need to help them. And if we can help them by learning some basic bioinformatic analysis, then it will be perfect. By the way, as I told you before, this class will be uploaded to YouTube, and so you can watch it again whenever you need by going to our webpage. But nevertheless, I recommend you to take notes with pen and paper, step by step, and repeat the exercise later by yourselves when we finish this class. So, today you will learn step by step how to do a heat map in R if you do not know R from scratch, from zero. So, the steps are 4. First, we will show you how to install R and RStudio. Then we will order all the data, all the normalized data before using R. We will use Excel. Then we will plot the heat map, and then we will use R for do this. And finally, we will present a figure, very nice figure, by using PowerPoint from that plot that we will plot with Heatmap. So, this is all that we are going to do right now. But what is a heat map, right? Why do we need heat maps? A heat map is a very, very common and useful representation that help us to explore how our data behaves in an unbiased and impartial fashion. So let's go simple. A heat map is composed of 5 components. The x-axis, that will represent our samples. For example, patients, cell lines, each sample will be here in the x-axis, patient 1, patient 2, patient 3, etc., or cell line 1, cell line 2, cell line 3. Then we have the y-axis, that will show the features of each patient. For example, these features can be a gene expression, for example, gene 1, gene 2, gene 3, gene 4, but in our case will be CpG beta value methylation, CpG1, CpG2, CpG3 for each type of patient. Then the third component is the color heat map by itself. This where the gene expression value or the methylation beta value is of a specific gene or of a specific CpG for a specific patient, and is represented in color. In this case, the colors are represented in green and red. The more green, the less methylation, and the more red, the more methylation this CpG has for that precise patient. So, the fourth component are the classifier bars. You can see here in orange, green, red, blue. This is entirely optional. This is not, if you don't want this, you don't need it. But we will do it for completing our heat map. So, this classifier bar classify our data by its phenotype. For example, this bar here, orange and green, will tell us which patients are male in green and which patients are female in orange. But this other bar here, red and blue, will tell us if the type of cancer comes from the blood or from the bone marrow in blue. And finally, we have the fifth component, and one of the most important of the heat map, the dendrogram here. So, this is called a cluster dendrogram, and it shows us how the patients or the cell lines that cluster here in function of each CPG. So, the patients or cell lines will cluster in different groups depending on its methylation state or depending on the gene expression for each type of gene or for each type of CPG. Then, how to read a dendrogram, because many people don't know how to read this. So it's very simple. You have to read the dendrogram from the top to bottom. So first, we can see there are two big groups, 1 and 2, that our data is separated into two main groups. Basically, one big group that is unmethylated in this case, and one big group that is methylated for these 5 CPGs, mostly. But again, this group divides again into 2 subgroups, and the same for the other group, and so on and so on and so on till we reach each patient individually or each cell line individually. So these are the 5 components of a heat map, and now we will begin. But first, what are we going to use to plot this heat map? Well, we are going to use R, the R language. So, R, what is R? R is a language program that is perfect to work with data tables, such as tables from Excel tables, with clinical data, with expression data, methylation data, etc. And it's perfect to perform statistical analysis and generate great graphics and figures that will become very attractive for our papers. So, many people, when they hear R, they shake in fear. But believe me, when you start with R, you won't stop with it. You have to work hard, and then the learning curve is quite wide. It's quite big. But once you learn step by step, you will see that you will love R. So, first, and by the way, this data, the data that we are going to use in this case, in our case, I'm going to go to the desktop right now. Here in this folder we have our data, and you can see our data here. Now we will open, and you can see the data here. We have the name of the patients, is coded, the project, where is the site primary of the cancer, the gender of the patient, the researcher, and also you have the CPGs and the normalized beta values, because we are going to work with normalized methylation beta values. So the thing is that we are going to order all this with Excel right now. But many bioinformatics, if any bioinformatician that is watching this webinar right now is going to kill me, because real bioinformaticians never use Excel to order a data table, a data frame. They use R. And yes, I also use R to order my Excel. But since we are a starting webinar, we are a beginner's webinar, let's start with Excel, and you will see that it will become the same result with Excel or the same result with R. So don't worry. So, and by the way, very important. I don't know if you heard me before when I show you this data frame. I told you that this data, methylation beta values, are normalized data. This is not raw data. Why? Because raw data, you need to be, quite a bioinformatician. You need potent computers, and it's very time consuming. You need to know many languages to become this raw data into normalized data. So, for this webinar, we are only going to work with normalized data, which is faster. It's prepared already for statistical analysis, while raw data is not prepared for any kind of analysis. And we will only use R language to perform analysis on normalized data. So today, just only normalized data. And you will ask, well, where do I get this normalized data? There are many sources in cancer. There are many sources in cancer research. For example, we have sources of normalized data in TCGA, in the Cancer Genome Atlas, CBO Portal, GEO, Cosmic, and of course, our great bioinformaticians. Of course, these bioinformaticians will give us all the normalized data that we will ask them. They will process and normalize the raw data, and they will give us the normalized data. And with the normalized data, we can analyze by ourselves. We don't need to depend so much on our great friends, the bioinformaticians. And this is Manu Castro. He's a great bioinformatician, but he's a greater person and human being. He's great. Okay, so let's start. So, first of all, what we need to do is to install R. And how do we install R? Well, we need first this, okay? We need to install this program. So, the first thing that you're gonna do is go to Google, very simple. You have to write this down on paper and go to Google, and you have just to put R, very simple. And you go to the first link that will appear, the R project link, and then you go here to download R, very simple. Okay, there are many mirrors, but wherever, you can click anywhere. I click always the Zero Cloud mirror to download, and there you can download R in whatever, well, I'm using right now a Mac, but most of you are using Windows, so go to downloading Windows and then install, and then just download. And here we have .x executable that when it's downloaded, you will install it. I'm not going to install it right now because it's already installed, but later you can do it. Remember, see, if you are using a IGC or IGTP computer, you will need IT permission. So send the ticket to IT and whatever you need to install R. But of course, when you have installed R, you are very happy and you say, well, I'm going to start doing things with R. So you go with R, you open it, and you find yourself that this thing, very ugly, isn't it? It's quite a difficult thing to see. It's not very user-friendly, R, by itself. And this is a very this is a problematic thing. It's not a user-friendly environment, R, by itself. But because of this, bioinformaticians have created a good user-friendly environment that uses R, that is called R Studio, which is a software that uses R with a user-friendly environment. You will see. So let's shut down R, and let's go again to Google. Go to Google, and then we put here R Studio. Great. So you go to the first link, R Studio. Very nice. And you find here download. You go to download, and then you choose the free version. You go to download free version. If you have a Windows, it will download Windows automatically. I have a Mac, so Mac. And that's it. You wait till the download is complete, and then you execute it and install it. Remember, you have to install first R before installing R Studio, because then it won't work if you do it the other way around. So, okay, we have installed R and we have installed R Studio. So let's open R Studio. And this is R Studio. We can see it's more user-friendly. You can see more icons here. It's more beautiful. I mean, it's a lot of difference with normal R. So, RStudio. RStudio is composed by 4 windows. You can see here, 1 window, the 2nd window, the 3rd window, and the 4th. So, the first window. What is the first window? The first window is the script window. And here you can write all the commands, all the functions, the variables that you want to save. And then when you have all the things that you need to write, you run all the script by pressing run. And it will run all the script at once. But since we are starting to learn about R, we won't use today this script window. Then the second window here is the history window, where it shows everything that you have written in the past sessions of RStudio. I use it a lot. Then the third window here is the console window, and we are going to use this today. The console window, it allows us to put a function. Well, R is a good calculator, but also will allow us to write a function, and it will give us instantly, by pressing the enter key, the result of the function. And finally, the fourth window, the plot window. When we plot our heat map, we will see the heat map here, stored here. So, okay, very good. But before doing the heat map, we need to order our data. And our data, as I have explained before, it's a Excel table with the patient codes, different phenotypes of the patients, the site primary of the cancer, the gender of the patient, and here, the normalized beta methylation values. Okay, so with this one table, in order to do the heat map that we want to do, we need 2 tables. So from this table, we will generate 2 different tables. And we will do this with Excel. Excel, I don't know how to say it, Excel or Excel. These 2 tables that will come from that table are called beta_matrix.txt. And the second table, this is optional, but we'll use it, is the phenodata.txt. So, let's generate these 2 tables. Okay? So, first, let's generate this beta matrix table. How do we do it? Okay. So, before continuing, we need to see our data. We need to understand our data. And first of all, we see our data, and we found 2 big problems. The problem with the R language is that it's very, very picky. You need to give and order the data the way R wants. If you give it some data that is unordered, or it has some syntax errors, so it will give error. So there are 2 problems here with this table. The first problem is spaces, R spaces. You can see here, if you look closely, this column is called sample name, but it's called sample space name. And R doesn't like spaces. For example, here, investigator Ronald space Fisher, there's another space. Here we have space cell space project. So spaces are bad. So we need to replace them with some character that we want. And we usually, in bioinformatics, we change spaces for underscores. So we select everything in the Excel. You hear me? Okay. Select everything. And then we go to data. Okay. No, not to data, sorry. To home. Okay. We select everything, and we're going to find, and okay, here, in this thing, search sheet, you can see it here. In Windows, it's just Control F. We press here, we put here replace, okay? So, we put here a space, And we replace that space with an underscore. And we put replace all. Great. Very good. So the first problem is solved. Every space in the sheet, in the table, is replaced by an underscore. So first problem is solved. Then the second problem that we have, that R doesn't like, is numbers. But numbers at the rows and at the columns. We can see here that these columns don't have any numbers, but these rows have numbers, and that's a problem. The first column of our table can't have only numbers. We need to put some letter before or at the beginning or at the end of this number chain, you know? You will understand. Because if you put this table in R, it will say, no, this is an error, I don't understand this. So, to do so, we create in Excel a new column. We click this column, and we put here insert. Okay, and I will call this column patients code. Okay? And what I will do here is to use a function, very known Excel function, which is called concatenate. In Spanish is concatenar. And you need to just click, put here an equal sign, and put an if. Concatenar, concatenar. Okay? Concatenate in English. So, we'll select, and with concatenate we will create a new column with a letter before this number. You will understand right now. So I'm going to open this, and I'm going to write P underscore, and then comma, and then we will select this cell. And here you can see that this is not a number anymore. This is a character. This is a P followed by the numbers. It's not a number anymore. So R won't give us an error. So we copy here at this square, and we will create this concatenate function in every single cell that we have. So perfect. Now we have solved the two problems, spaces and numbers in row names or in the column names. So now we are ready to generate these two tables, beta matrix table and the phenodata table, from this single table. So let's start with the beta matrix table. This is the most important table. And if you remember the heat map, let's go again to see the heat map here. If you remember, the patients are at the x-axis, and the features, in our case, the CpG methylation beta values, are in the y-axis. So the problem that we see here is that, okay, our patients are not in the x-axis, are in the y-axis, from the top to the bottom. And our CpGs are not in the y-axis, they are in the horizontal x-axis. So first, what we need is to select the patient's code that we generated before. And the trick to select this is to press at the same time Control, Alt, and down. You can see here, you select everything. Then you press Control here, okay, and then again Alt, Command, down. And we selected everything that we need. The beta matrix table is just composed by the patients and the beta methylation CpGs. So we copy this with Control C, okay? And now we will gonna open a new Excel file. So we go to Excel, we new file, okay? Perfect. And we can see here. And then, as I told you before, we need to transpose the table, because we need the patients to be in the x-axis, not in the y-axis. So, previous to paste, we right-click this, right-click, paste special, paste special again, and we put here values and transpose. That's it. There we have the patients here in the x-axis and the CPGs at the y-axis. We are ready to perform the to create the heat map. With this table that we are going to save here, okay, we're going to save, add the webinar PhD folder. This we are going to call it beta matrix. But we are not going to save it as Excel. Very important. We are going to save this as a tab delimited text, as a .txt format file, not as an Excel, but as a .txt. Why? Because R likes more TXT. R doesn't like R doesn't like Excel, as bioinformaticians, you know. So let's save this beta matrix. Yes, of course, I want to save this. And we already have stored this as a .txt file. Okay, we eliminate this. We get out from this, and let's return to our original patient data frame. So the second step, we already done this. We already have done this, and then we need to perform this table. We need to create this table, which is phenodata.txt. The phenodata.txt table will allow us to create this classifier bars. This is optional. You don't need this. You can make a heat map without this. But since it's quite good to have these classifier bars in our heat maps, we are gonna learn how to do this. So let's go on and do the phenodata.txt table. So we return to our data table. By the way, we will give you this table after all this webinar. You will produce the same data that we are going to produce, so don't worry, you will train again. So let's return to the patients table, and for the phenodata we need 4 tables. In our case, we need the patient's code table, the patient's code column here, okay, selected. Then we need the primary site of the tumor, because I want to classify these patients for each type of site primary. For example, if it's from the blood or if it's from the bone marrow. And then I also want to know if these patients are female or male. So I selected these 3 columns. Then we copy this and we open a new Excel. Okay, new Excel. And then we copy it, we paste this, Control V, and that's it. Great. We have the patient's code, the site primary, and the gender. Now, the thing is, the phenodata is going to give us a color depending on the patient. And now you will understand what I mean. We are going to generate 2 new columns here in Excel. We're going to call this new column color site, okay? And the second column we're going to call it color gender. Okay. So the thing is that in Excel we need to give a number, a color to each type of site primary. For example, if it's blood, we need to call it, for example, red. Green. Red. Okay, but the bone marrow, I want it to be blue. Okay? But doing this manually like this will become very tedious, right? So in Excel there is a great function that is called conditionals. It's called the if statement. In Spanish it's called si. Si esto, pues aquello. If that, then that. So I'm going to tell this I'm going to tell Excel that if, parenthesis, this cell is blood, between quotation marks, comma, you will give us red. But if it's not blood, if it's another thing, you will give us blue. And then we close this. Great. And you see that all bloods are red, but bone marrows are blue. You can see here. Very easy, very straightforward. It's very, very, very nice to do this. And for the color gender, very simple. We are going to repeat this, but with the gender columns. So, if, open, this cell is female, then you will give us, for example, green. But if it's not female, you will give us, for example, orange. Nice. Then we press here again, and you will see that the males are orange and the females are green. No, it's okay. Okay, so perfect. This is the phenodata table. Very simple to do. And of course, we need to save this new table. We will call it phenodata. And we will save it as a .txt at the webinar PhD folder. Yes. So, we can get out from here. Okay. Can minimize here. And we can see that in our webinar PhD folder, we have our main Excel table and two new tables, beta matrix table.txt and phenodata table.txt. With these two tables, we are ready to perform a heatmap to create a heatmap in our studio. So, yes.
We are asking if you don't need to transpose the phenodata table.
No, good question. They are asking me if we need to transpose the phenodata table. No, the phenodata table needs to be in the patients in the y-axis. So, no problem with that. We can take our patient's table and put the phenodata without transposing. The beta matrix table, or if you are doing gene expression, the gene expression matrix table, you will need to transpose because you need to have the patients at the x-axis and then the genes in the gene expression or the CPGs in the methylation array at the y-axis. So, we have these two tables. So, I think we are ready to go to our studio. Okay, so let's open our studio. Very good. And we see here, do not look at this, no this, no this. Just look at the console terminal right now, okay? This is quite dirty. You see a lot of letters here, a lot of words. Let's clean this. How do we clean the console terminal, the console window? You just press the Control key and the L key of the keyboard. So Control and L. And that's it. It's clean. At the same time, Control and L. So you can see now a console terminal cleaner, more clean. So R is very special. R seems difficult at the first place, but R simply uses functions by functions and variables. So you will understand what I mean. I mean, learning R without an objective, it's impossible. So since we have the objective of creating a heat map, you will learn in this process, step by step, you will learn how to speak in R while we are doing this heat map. And you will learn the grammar, the vocabulary of R with this class. So, first of all, we need to know, the first thing that we do always when we go with RStudio, when we open a terminal in RStudio, is we need to know where is R right now. In which folder is R situated? So we are going to write a function which is called getWD, and like this, with an open and a closed parenthesis. This is a function. A function is basically a word here, a word, and two parentheses. And inside this parenthesis, you can have arguments. For example, argument A separated by a comma, and then another argument, another argument. In this case, this function getWD doesn't need any arguments. You can put it like this, and then you press enter. What this tells us, getWD function, is where is R situated right now, in which folder is situated. And we can see that is situated in the users Alberto Buenacosta folder. But this is not the folder I want. I want R to be in this folder, which is in the desktop and webinar PhD. Very good. So, to change the working directory, to change the WD of R, we need another function, which is called setWD. So we write setWD, we open a parenthesis, and then we write our destination. So in Windows, you should write this C:/ and then users Alberto Buenacosta desktop webinar PhD. But careful, then close the parenthesis. But this will give me an error because I'm working with Mac. This C:/ is only in Windows. When we are working with Mac or with Ubuntu, we just need to write the same, but without the C and colon. So, and that's it. So we clean this with Ctrl-L, and then we repeat the getWD function, and we see that, okay, perfect, R is now situated in the new webinar PhD folder that is in our desktop. Okay, in this folder we have the beta matrix table and the phenodata table. Okay, you have already learned two basic functions of R, getWD and setWD. Now, before getting to the heat maps, we need to install packages. And what is a package? R works, as I said, with functions, getWD, setWD, but okay, other users, external users from the RStudio, can create new functions, can create new content for R. And that is why we need to install packages that are online, that are created by the community, and then we install it to the into the RStudio, and then just we can use whatever they created. So in this case, we need to install three types of packages, which are called, as you can see here, ggplot2, which is a very famous R package. Then the other package is gplots, and the third package is heatmap.3. We need to install them. And to do so, we use the function install.packages, okay? And we open this parenthesis, we open the quotation marks, and we write ggplot2. And then we install it. We wait a little bit, it will think a little bit, okay, it's connecting to the webs, and that's it. ggplot, it's already installed, but we need also to load. It's not the same installing a package and loading a package. The package ggplot2, it's installed, but we need to load it to the R session. And how do we do this? With a new function called library, parenthesis, ggplot2, and enter. Great. Now ggplot2 is installed and loaded. Then we need the other package, gplots. Okay, well, the same, install.packages gplots, and we install it. Press enter, and it's installing. Okay, it's already installed, very quick. Gplots is very quick. And we go again, it's installed, but it's not loaded. We need to put library, open parentheses, gplots, enter. Okay, now it's loaded. So we have installed ggplots, loaded ggplots, installed gplots, and loaded gplots. Then we need the final and most important in this case package which is called Heatmap.3. So let's clean a little bit. Control L to clean this. We go to install packages, Heatmap.3, and let's see. Oh, there's a problem here. The previous week before this webinar, this didn't happen. This is new. Why? Because R, it's community actualized. You know, it's every month, every 2 months, R is always actualizing new versions, uploading new versions, and this is problem for the packages. So this package for this version of R, it's not available, but don't worry. We can find this package in Google. So a very good, let's go to google.com again.
They are asking if we need to install the packages every time we want to use we want to generate a Heatmap.
Very good question. So before installing Heatmap.3, we are going to answer that question. No, that's a very good question. When you do this install packages, blah blah blah, ggplots, ggplot2, you only need once. Then when you restart RStudio, you won't need to install it again, but you will need to load it. This is very important, very good question. You won't need to install it again, but you will need to load it. ggplot2. Always you will need to load with library function. Okay, so once it's installed, it's okay, but you need to load it every time you open a new RStudio session. So let's go to google.com and let's look for Heatmap.3, and I'm going to search for GitHub. GitHub is a really nice repository, an archive of packages that there are not anymore in R as install.packages, but here we can install it manually. So we put Heatmap.3 in GitHub and in google.com, and we find the first one. Okay, careful, there is another package that is called Heatmap3, not Heatmap.3. Very careful. It's very good, Laure. Good catch. Heatmap.3. Okay, so this, what you see here, everything here, it's the package, but we are gonna put it in RStudio manually. So we're gonna, I'm gonna eliminate this, and we're gonna take all this, oh, what is going on? Aye. Okay, we're gonna take all of this, and we're gonna select it and copy with Control C. We copy all of this.
It's like you are creating your own package.
That's it. We are creating our own package. So where we have copied all the package, and we Control V, we copy, we paste it here, and then press enter.
They are also asking why when we install we put the quotation.
Yes, very nice questions.
And when we
Very nice questions.
load it, it's not necessary.
Yes. You can add the quotation marks when you are using library, but it's not necessary. But in the install.packages, it's mandatory. You need to use the quotation marks. Why? Because the quotation marks distinguish variables. You don't need to know this, but you will know what I mean later. So I pasted the heatmap.3 package, I pressed enter, and we already loaded. Okay, I pressed enter and it's already loaded. So let me see if it's loaded. Very good, it's loaded perfectly. Okay, so we installed the 3 packages. Now we have all the necessary packages, and finally we are going to plot the heat map. So first of all, remember, we are at our folder. Our studio is located at our webinar PhD folder, where are the beta matrix table, the phenodata table. So now we are going to tell our studio to open the phenodata table and the beta matrix table. How do we do this? We're going to create a variable. And how do we create a variable? Let's create this variable phenodata. And we are going to say, we're going to write this thing here. It's a minus and like a hyphen. I don't know how to call this, like a straight line or horizontal straight line. And then after this, we are going to write a function which is called read.table. We open parentheses, and let's put some arguments here. So the first argument inside the read function table is file. So we write file equal sign, quotation marks, and phenodata.txt, and close quotation. This is the name of this phenodata. Is the name of the table. Then the second argument, we write a comma to write the second argument, and the second argument is header. Header equal sign true. This has to be all in caps, okay? It can be like this. No, like this, okay? This is very important because the first columns will be considered as the header of the table. Okay, and the third argument is very important, strings as factors. Equal sign false. Okay, false also, it can be like this, all in caps, activated, okay? And then with these 3 arguments, we press enter. Okay. Also, we are going to save another variable called beta matrix table. Beta matrix dash, okay? Minus dash, and then again read.table file. And this, in this case, is called, if you remember, beta underscore matrix.txt. Header also is true, and strings as factors, is false. Okay, perfect. We already stored the phenodata table and the beta matrix table in our studio session. If we want to look a little bit to this data, we can write phenodata. We can write this, and it will show us all the data, as you can see here. But if we only want to see the 6 first columns, because this is too messy, too much information, we can, let me clean this, we can write the function head, parenthesis, phenodata. Okay? And this is it. Okay, the 6 first column, the first 6 rows. And if you want the last 6 rows, you can write tail, head and tail phenodata. Okay, you see the last 6 rows and the first 6 rows. Perfect. Everything is perfect here. And the same for beta matrix, of course. Works perfectly. Nice. Let's clean this with Control L. And okay, we are now ready to do the heat map. But the heat map function, heatmap.r, yes, needs a matrix. What is a matrix? Well, a matrix is, it's difficult to explain right now, but just a matrix, what we are working with right now, beta matrix table, this table, it's not a matrix right now, it's a data frame. Why it's a data frame? Because it combines strings, character names, which are the patients, and combines them with CpG beta methylation values, which are numeric. And we need a matrix that there are only CpG numbers, the beta methylation values, not patient values. You will understand why. So, we need to create a new matrix from this beta matrix. In other words, we need to eliminate this column, patient's code, to create the matrix. So, we're going to create this matrix that we're going to call it matrix underscore heatmap. Okay? And then, okay, less than symbol, dash symbol, and we write this function as dot matrix, which is a function that creates a matrix. And inside the arguments, we want to create a matrix from the beta matrix table. This is the most difficult thing that we are going to do today, so don't worry, this exact line. So as matrix, beta matrix, and we are going to use something called cloud-dator. Cloud-dator, well, in English is brackets. So brackets, symbols, are very useful. So this means that, for example, let me delete this again. If we take beta matrix table and we put, for example, 1 and 1, it will give us the value that is on the row 1, column 1. You understand, right? This is the first row and the first column. For example, if we put beta matrix 2 and 10, this is the second row, the 10th column. It's very simple. So let's write again the matrix heatmap variable as matrix beta matrix, and then we open the brackets and the comma. So at the left, I won't write anything because I want to get all the rows, all the CpGs. But since we want to get rid of the first column, if you remember, because a matrix only has beta values, numeric beta values, we are going to tell R to take the second column until the final column of the beta matrix. And the final column is a function that is called encall beta matrix. And we close everything. And we press enter. Okay, this is the matrix. So we can see here head matrix heatmap. Okay, here we can see. And we can see that the first column has disappeared. And now this is only numeric values, CpG methylation values, numerical values. Very good. But there is something missing. We need these rows to be named as the CpGs. CpG1, CpG2, CpG3. So in order to do so, we are going to write this function. This is the most difficult part, don't worry. Then it's very simple. Heatmap. And I'm saying for the row names of matrix heatmap, I want them to call them as beta matrix, and the first column, if you remember, the CpG column, which is called like this in this case. This $sign help us to select a column. This is the methylation beta values for this patient, but this first column of beta matrix is the CpG. So we enter here, and we can see here head matrix heatmap, then we can see here how the row names have renamed into our CPG names. Perfect. That's very good. So now let's plot the heat map, which is the most easy thing. So heatmap dot 3, and then we just put matrix heatmap. And take a look here. Enter. Okay, and perfect. Here we have a heat map. A very ugly heat map because too red, too yellow, too white. I don't like it. So this is a heat map. So we created a heat map. But let's tune it. Let's change colors. Let's change some things, right? More appealing to our eyes. So we write again heatmap.3 matrix heatmap, and then we are going to write another argument inside this function, comma, which is called, an argument is called col, which is color, and green, red, 200. This is something to change color. It's a very common use thing to change color in heat maps, and then press enter. And then we see that, okay, this is better. The CP, then here we can see that the methylation values that are in green are low methylated, are down methylated, and the red ones are up methylated, more methylated. So here we can see that it's more beautiful to our eyes. Then another thing that we don't want here is this. This dendrogram is very useful because it separates this heat map into two big groups, this one and this one. But this dendrogram is not very useful. We don't need it. So
They are asking if they want pink and blue, for example.
yeah, pink and blue. Well, it's the thing is that the gplots package that gives you the colors, it has a limited set of colors. For example, let me try. I think it's blue, red. You can see here blue, red. But pink and yellow, no. Pink and yellow, you need to download another package which is called rcolor brewer. Okay? You need to install the packages rcolor brewer, a library rcolor brewer, and then put the function here. I won't show you here, but it's very easy. It's just applying the things that we are showing you today and put the function here. Change it. Yeah, you can change every color you want. It's very, very, very tunable, very modifiable. So let's return to the green red. Let's clean this. But I said that we wanted to eliminate this dendrogram because it's not very informative, really. We only need this one. So we add a new argument here.
They are asking for the 200 number.
The 200. Which one?
Green, red.
Yes. It's like the color shade. It's like the color shade. You put here one. Sorry, blue, red now. Green, red. Red. And that's it. If you put here a 2, you will see that it's like the scale. It just gives you 2 colors or
Shades.
the shades of colors. And I am asking him to put 200 shades of green and red in between, you see? If we put 2,000, we can put 2,000 shades, but it will be the same. Our eyes don't distinguish so many colors. If we put 20, okay, but you can see here that they are becoming more distinguishable. So I like the number 200 because we cannot distinguish with our eyes. So I told you that we don't need this dendrogram, so we just put this here. A new argument called dendrogram equals column, and I'm telling just draw the column dendrogram, and that's it. It disappears. This great, very nice. But there is still missing one thing, right? What is going on with the color bars here? How it is called? The classifier bars. We need to put them here, right? That is why we have the phenodata table. It's optional, but it will add some value to our information. So, in order to put the bars, we need to create a new variable called CLab. CLab, we are going to create a new variable called CLab, and with the cbind function. The cbind function will take a column and bind to another column. I mean, it's very easy to understand. You take the phenodata table, and remember, we have this color site column in the phenodata table, and you select it, color site. And then we want another column with the colors of the gender that we already prepared in the Excel, if you remember. So we create a new data frame called CLab. And as you can see here, it's a matrix with the colors in order. So with the CLab variable, we can add to the Heatmap another argument called side colors equals to CLab. And then we have this. It's a little bit small. Let me fix this. Okay. And then we have these columns, the bars. If we want only just one bar, for example, the gender bar, and we don't need this blood, bone marrow, we have to create another CLab with just, for example, the phenodata color gender. But let's see what is going on with if we add a CLab with a cbind with only one column. You will see. Okay, let's redo the heatmap.3 matrix heatmap call dendrogram call site colors CLab. It will give us this, so it's perfect.
There's a question.
Yes.
They ask what methods and distance are you using?
Very
Does
good.
the script allow to
Nice question. That is there's one thing that I was going to answer right now. The distance is Euclidean. Distance, what does distance means? Well, it's very difficult, it's a statistical thing. It's the distance between each patient depending on the gene or of the methylation expression, the methylation values, no? It's like statistical distances. The distance allow us to create this clustered dendrogram and order our patients into different types of groups. Well, the distance is Euclidean, which is the most common and most used distance method used in dendrograms and heatmap clusters. So distance, it's by default is Euclidean. So we don't need to put this. And this is the distance that we use every single day in bioinformatics. So you don't have to worry. I'm not going to change that, but yes, distance is Euclidean. So that's it. And we have this heatmap. It's already done. I'm going to put, again, the CLab with the two bars because I like it more. Let me see here. Color gender. Let me see here. Comma. Pheno data. Color site. Okay. And let's redo with the two bars. Okay, I like this more. So, okay, we have already the we already have the heat map. We could also add a legend here to know what the color means. You know, orange is female, green is male, blood is red is blood, blue is bone marrow. We can add here a little legend with R, which I have the code here because it's quite large. You don't need it, but the thing is that I prefer to do the legends of a heat map in PowerPoint. You will see here. Here we have the legend. If we add this, well, sometimes it doesn't work. It's I don't usually like this to use this legend formula because you have to, you see, sometimes appears here. You need to calibrate the distance of opinion. You see, it's very difficult. So I prefer to do this by hand, to add this with PowerPoint, and you will see. Let's again create the heat map without the legend. And now we have the heat map. So we can export the image, as a PDF, but in our case, we are going to copy this as a clipboard in the paste. So I want a big heat map, so I'm going to maintain the aspect ratio, maintain the aspect ratio. So very big heat map, maybe 900. So copy, not bad, but I like it more. Okay, let's copy again, copy plot. Okay, it's already copied. So to modify a little bit more our heat map, let's go to the PowerPoint, which is the last thing that we are going to do here. Sorry, let me get what is going on?
And you can add as many phenodata as you want.
Yes, we can add as many phenodata as we want. 3 bars, 4 bars, 5 bars, 6 bars, anything that we want. So let me go to the presentation because I cannot see it. Okay, so let's open a new PowerPoint.
They are also asking if there's any function to calculate the p-value of the classifier bars.
Of the classified bars, let me in this case, no, we don't have no, we don't have it. But there is a way. Because I've done this, but it's too long to do this. Yeah. So we can add a legend here manually. I usually do this, we take this and take that. It's very manual thing, and then with the you understand the drift, right? So here you can take red. Okay, here you can take the yellow. You get the drift. And then
This is possible to do in Windows?
in Windows, what do you mean?
I
think so. I did it. Yeah. And then we just, you get the drift. You need to do this with patience, with time, clean things. And for example, this is female, the next is male, and you just put this on a good position, etc. Okay, so this is it. And of course, you can also go here, format of the image, and this is, you can eliminate this. You can also eliminate the name of the patient because right now we don't need them. And then we just add, for example, CPG1, CPG2, etc. And then you will have a good heat map to present to everyone and to present to maybe a paper. So that is all. It has, how much time have we spent? 1 hour?
Yeah.
1 hour. Okay, so this is how we do a heat map. So let's continue a little bit, okay? Just 5 more minutes and then we are done, okay? To complete the thing. Some people ask me if we can know which patients are in these places, which patients are from this big group and which patients are from this big group. This is a very common question that many people make me. So there is a little function to calculate this, and we need to perform this dendrogram but without the heat map. How do we do this? Well, we create a variable called distance, which uses the function dist. And then we take inside this function, we perform another function which is called T, which means transpose. And what we are going to transpose? The matrix heatmap. Okay? This distance calculates all the distances that we already calculated in the heatmap. So now we are going to calculate the dendrogram, and that is, we call it another variable called dendrogram, and we call it hclust. This is a function called hclust. And we are going to say perform a dendrogram of these distances, and that's it. And then we can plot dendrogram. Okay, it's a little bit messy. It's a little messy, but don't worry, because we don't need this. So you can see here that we need only this group and this group. So we are going to cut the dendrogram more or less here. You see? So we're going to cut with something that we call a function upline. This is a lot of things, but don't worry, this is all saved. This is all saved in YouTube. So h, more or less, this is 1.7. Here we need to cut here and here. The call is red for the line. Okay. And then here we can see here that we have cut the dendrogram in this place and in this place. So we just generate the groups. We generate a variable called groups with the function ordered sort, and then we use the function cut tree. Let's cut tree of the dendrogram. At what height? Well, at this height, 1.7. And that's it. If we write this variable, we can see that this patient is in group 2, this patient is in group 2, this patient is in group 2, but these patients are in group 1. Then we can write this table with the function write table, groups, and we're going to call this table groups.txt. And then this table is saved, at this webinar page here, groups. So perfect, that's it. So this is everything. I'm sorry it has been quite long, but R is difficult. I wanted to show you how to perform a gene ontology, but we have no time at all. For another day is very easy. I thought we had time, but for another day we will perform some gene ontology, very short webinar, 20 minutes webinar maybe. And so the thing is that you have seen that R is quite difficult at the first place. When you see, well, all those functions, all those variables, you can become lost in all this sea of information. But difficult things don't mean that are impossible. You need to be like Immanuel Kant, sapere aude. You need to dare to know. You need to work hard, little by little, step by step, and you will learn how to perform everything with R. And
some
as
advice where to start.
Where to start? Well, the thing is how I started. I didn't perform a bioinformatician's course. I didn't went to do a master of bioinformatics. I just learned by myself and with the help of many bioinformaticians of our group. How do we start? Well, the first thing that you need to become better with R is to have an objective. You can't study R without having an objective. For example, I want to do a heat map. I don't know how to do it. Well, let's go. And so let's do this. So step by step, what do I need to perform a heat map? Okay, we need this. We need to the get WD function, set WD function. So little by little, when I don't know what to do, I go to google.com and I ask Google what to do. For example, Dendrogram art generation, for example. And Google will give me a lot of chances, a lot of programs to generate dendrograms or heatmaps or many things. And if you have many doubts, you can go to BioStars forums, which they will answer all your questions. This is a very, very good community, and if you have a questions, well, you put it there. And many questions that you are asking yourself, many people have already asked them in BioStars. So that's it. That is my advice. You have to learn step by step. And of course, if you want to know more about anything that you want, if you want to know more about gene ontology, for example, let us know. If you want to know more about how to analyze a raw data of methylation analysis, for example, of a methylation array, you can ask us and we will prepare more webinars. These webinars will be available in YouTube, so don't worry. You can access to our webpage here, RutiPhD.wordpress.com, and you will see a link to our YouTube pages and to all a very well-ordered script to perform heatmaps, to perform many other types of analysis that we are going to put there, scripts, user-friendly scripts, as the ones we perform right now. And that's it. And as Spinoza said, good and beautiful things are very difficult and are very rare. So we need to work with patience, and maybe one day we will master our studio and all what we need. So patience, and any questions you can ask me later, whatever you want. We are here for helping you. I know this is very difficult, but thank you for assisting. So thank you.